virtual reality. It is an oxymoron. We know that we live in the real world, but yet living in this real world, we can experience the virtual thing. Something that doesn't even exist. And even if it exists, we can't experience it in real time. Now, this is made possible by virtual reality because we can imagine and make our surroundings like our thought, our dream through this technology. It is just wonderful. And today in this video, we are going to talk about this excessively high-end technology, virtual reality. Don't underestimate it. It can create massive change in our real-time world experience.
Now, before moving on to the rest of the details about how it works and what are the advantages and disadvantages, I would like to talk about what is this virtual reality. But it is nothing but the use of computer modeling and simulation to enable a person to interact with an artificial three-dimensional visual or other sensory environment. A computer-generated environment simulates reality by means of interactive devices that sends and receive information and are worn as goggles, headset, gloves or body suits. The illusion of being in the created environment is accomplished by motion sensors that pick up users' movements. At this stage, we know that what is this VR technology, but what we still don't know that how does it work. This how can we make our room into a 3D imagination. Yes, let us call it imagination because it doesn't exist at all. Now is the time to learn the basics, the three types of tracking through which this technology, VR technology, can be made into a lifelike reality. Although it is already a reality by now because many have made this technology possible. VR headsets like Oculus Rift and PlayStation VR are often referred as HMDs, which simply means head-mounted displays. The goal here is to create what appears to be a life-size 3D virtual environment without the boundaries we actually associate with a TV or computer screens. So whatever way you look, the screen mounted to your face allows you. This is unlike augmented reality, which overlays graphics onto your view of real world. VR headsets use either two feeds sent to one display or two LCD displays, one per eye. There are also lenses which are placed between your eyes and the pixels, which is why the devices are often called goggles. In some instances, they can be adjusted to match the distance between your eyes, varying from person to person. These lenses focus and reshape the picture for each eye and create a stereoscopic 3D image by angling the two images to mimic how each of your two eyes view the world ever so slightly differently. One important way VR headsets can increase immersion is to increase the field of view, that is, how wide the picture is. A 360-degree display would be too expensive and unnecessary. Most high-end headsets make do with 100 or 110-degree field of view, which is wide enough to do the trick. And for the resulting picture to be at all convincing, a minimum frame rate of around 60 FPS is needed to avoid stuttering or users feeling sick. Okay, so after learning about the basics, let us move on to the three types of tracking. Firstly, head tracking. Head tracking means that when we wear a VR headset, the picture in front of you shifts as you look up, down and side to side or angle your head. A system called 6 degrees of freedom or 6DOF plots your head in terms of X, Y and Z axis respectively to measure head movements forward, backwards, side to side, shoulder to shoulder, otherwise known as pitch, yaw and roll. There are a few different internal components which can be used in a head tracking system, such as gyroscope, accelerometer and magnetometer. Sony's PSVR also uses 9 LEDs dotted around the headset to provide 360-degree head tracking thanks to an external camera monitoring these signals, while Oculus Rift has 20 not as bright LEDs. Head tracking tech needs low latency to be effective. We are talking 50 milliseconds or less, or we will detect the lag between when we turn our head and when the VR environment changes. Finally, headphones can be used to increase the sense of immersion. After head tracking, we now move on to eye tracking. It is not available on Rift, Vive or PSVR, but it will feature in FOVE's very promising VR headset. Well, an infrared sensor monitors your eyes inside the headset, so FOV knows where your eyes are looking in virtual reality. The main advantage of this, apart from allowing in-game characters to more precisely react to where you are looking, is to make depth of field more realistic. In standard VR headsets, everything is in pinch-sharp focus, which isn't how we are used to experience the world. In our eyes, look at an object at distance, for instance the foreground blurs and vice versa. By tracking our eyes, FOV's graphic engine can simulate this in 3D space in VR. That's right, nerd can be good. Headsets still need high-resolution displays to avoid the effect of looking through a grid. Also, when our eyes focus on needs to look as lifelike as possible. The next and final piece of this tracking devices or tracking technologies is the motion tracking. It is pretty similar to Valve's Lighthouse positioning tracking system and HTC's controller for its Vive headsets. It involves two base stations around the room which sweep the area with lasers. These can detect the precise position of your head and both hands based on the timing of when they hit each photocell sensor on both the headset and around each handheld controller. Other input methods can include anything from hooking an Xbox controller or joystick. When it comes to tracking your physical position within a room, Oculus now offers an experience to match the HTC. For a while, we have seen the Leap Motion accessory, which uses an infrared sensor to track hand movements, strapped to the front of Oculus dev kits. We have also tried a few equipments with cameras tracking your flying bodies. Sony is also hunting around this area. If a recent patent is anything to go by, the film details a VR tracking system based on light and mirrors that uses a beam projector to determine the position of the players.